We're going to add and subtract polynomials. The first thing we're actually going to do, though, is ask about the degree of the polynomials. This first one is 8. It's staring you right in the face. It is the exponent of the variable. It has absolutely nothing to do with the coefficient or the constants. Number 2 is a little bit more complicated because we have a 1, a 2, a 3 variables. And here's what's going to happen. This is a monomial. I mean, that's what we've been talking about. A monomial is going to be one term. Mono is 1, okay? And so what you're going to do is if you have a monomial like this, you're going to add up all the exponents. So we have 4 plus 1 plus 2. The degree on this is 7. Right here, another monomial has a 1 there, 3 here, 9 here. The degree on this one is 13. So now we're upgrading to a polynomial, which means more than one term. In fact, specifically it refers to more than like 3 terms, but that's just because, you know, monomial is 1 term, a binomial is 2 terms, a trinomial is 3 terms, and a poly is many terms. So, I mean, technically, yes, we can still go ahead and call this a polynomial, even though it's 3 terms. Okay. So what we're going to do is we want to write it first in standard form. Standard form is going to look like this. The biggest degree term gets written first, then the next biggest degree term, then, I mean, it just goes down from there. So this guy had a degree of 5, so he's biggest, then 2, then 1. So we did that, and now we are supposed to identify the degree. The degree is going to be, I'm going to write it out over here, the degree is 5. So if you're like, well, wait, how come up here it was 7? This was a monomial, and so we added up all of those. This is a polynomial where you just get the biggest exponent on a term. So we got 5 there. And then let's see, it says we also want the leading coefficient. Well, the leading coefficient, LC, is going to be 10. And if you're like, well, I would have chosen 3 because he was out front. Yeah, it was until it was in standard form. And this is standard form. And then classify the polynomial by the number of terms. Well, hey, trinomial, right? So trinomial. I'll try and answer this one a little bit more cleanly since I kind of put this a little sloppily around here. So let's go over here and say, all right, standard form first. Let me zoom in a little bit. 3 into the 4th. Let's see. So this guy has a degree of 4. And then plus 2/9 n squared because he's got 2. And you might think, well, hey, doesn't this one have 2? No, pi is a number. Pi is a constant term, 3.14, and we don't really, you know, we'll just stop after that, okay? You might know more, but that's not the point today. So this is in standard form, and I'll write that here. This is the standard form of that one, okay? And then next, we want the degree. The degree is going to be 4. How come? Because of that right there. Biggest exponent on a variable. And then the leading coefficient is going to equal 3 right there. And then this is a trinomial. Because again, there are 3 terms. 1, a 2, a 3. Right here, we can go ahead and say, since it's on my mind, I'm going to go ahead and say this is a monomial because it is 1 term. If there was like a plus 2, well, then all of a sudden this would become a binomial because there'd be 2 terms, but no, not this one. Now, it's in standard form, so I'm just going to state that in standard form, okay, because there are no other terms. And then the degree is going to be 5 because of our friend right here. And then here's kind of the funny answer. The leading coefficient is the square root of 14 because this is an actual number It's just we don't have like the decimal equivalent of it hanging out there, kind of like pi, right? Now, the monthly profit for a small company is represented by that, where X is the number of beds sold. Classify the polynomial by the number of terms, then identify the degree. So, by the way, this word problem has almost nothing to do with doing the problem. In fact, they kind of suckered me. I was starting to solve, but no. So the number of terms, this is a trinomial because it has 1, 2, 3 terms, and the degree is 5 because of that 5 right there. Done. Find the sum. Okay, so now this is something that you could have a couple different approaches on. Some people are going to want to simplify this a little bit first. Others of you will not. So I'm going to do this kind of two different ways. This one I'm going to simplify first. So what do I mean by simplify? Well, this first set right here, this set of parentheses, there's nothing to be done. So I'm just going to remove the parentheses. Boom, it's simplified. Now, what I can do here is a positive negative. That's minus 8t squared. Positive is plus 4t. Positive negative, that's minus 3. And you might be thinking, well, that seems a little pointless because isn't that the same as that, and that? Yeah, kind of is. Yeah, when you're adding, it's not going to change the symbols at all because, you know, even a positive is still positive, right? So, like I said, some of you might want to just do this and go, listen, negative 2t squared, negative 8t squared, which are here, and here is negative 10t squared. And then negative 7t plus 4t, that is negative 3t. By the way, that's here and here. And then lastly, 5 plus negative 3, that's 2, which is there and there. And you're basically free to do that. That is the answer right here. So when it comes to adding, if you can see it without simplifying it, go for it. Like number 9, 8y squared plus 5y squared, that's 13y squared. Negative 2y plus negative 7y, that's negative 9y. And then 4 plus is just plus 4. We're done. Now this one is not in standard form, so I guess part of the challenge is that we're going to ask you to write in standard form always. Like, I know it doesn't say it, but standard form is like the, hey, do this. We want you to always do this. So what I'm going to do is actually focus here first, because that's the biggest degree term, and that's how standard form works. So negative 5 plus 8 is 3k cubed. And changing colors, 3k minus 4k, that's negative k. 9 plus 8, 17. Done. Let's see. Biggest degree term, is that guy. Negative 5q to the third. And if you're like, how do you know it's negative? If I were to add a negative, it's still negative, right? So let's keep going, changing colors here. 3q squared plus 2q squared is plus 5q squared. Negative 7q plus 8q, that's just plus q. And then negative 6 has no one to match with. That's just done. Now, finding the difference is going to be a little, the pun here is going to be a little different because you might want to go ahead and distribute that negative and get negative t. And if you're like, how's that different? It was a positive t, and now it's a negative t. And then you're going to distribute the negative again here and get plus 11. Again, it was negative, and a negative is positive. And at this point, it's basically the same stuff. I mean, if you'd like, you can write this stuff down next, just so that it's all on the same line, just for the sake of thinking through it. But the idea is basically, okay, hey, now we have a t cubed. Oh, he doesn't have any friends, so he's first. We have a negative 5t squared. Okay, he doesn't have any friends either, so he's next. Negative 7 and positive 11. Well, that's positive 4. And you'll notice, or at least hopefully you notice, there's a big gap here. And I left this gap because, one, we have this guy left over. And because if we're doing standard form, cubed, squared, regular variable, and then the constant. So anyway, this guy drops straight down here, minus t. And then just because I've colored all over this thing, I'm going to just highlight my answer like this. There's the highlighted answer. Okay, 13. So now, okay, on this one, I distributed right here. Over here, I don't feel like distributing. I think I'd like to just look at it and look for the like terms. So like, here's a W, constant. No other constants. Cubed, squared, cool. So basically now what I'm going to do is I'm going to do negative 3w cubed, which is 3w cubed. And then let's see, we're to here now. Negative w squared is just negative w squared. Obviously, I call this w squared. I didn't call it positive w squared. I think that's something that we don't usually do. If we don't say that it's negative, automatically it's positive, right? Now, so this one is going to take a little bit of thought. Negative w minus 6w. Well, that's negative 7w. And then last but not least is our negative 13. And we are finished. 14. X to the 4th. He's got no friends. There are no x cubes. We have x squared and x squared. So we're going to have negative x squared minus negative x squared. That is going to be negative x squared plus 6x squared. So that's plus 5x squared because negative 1 plus 6, right? Let's see. Next, we have 8x, but don't forget it's negative 8x. And then our plus 9 is just left over. So there we go. We're done with that one. Okay. G to the third. G squared, regular g, and then the constant. So let's start with the g cubed. Negative 5g cubed minus 12g cubed. So that's negative 17g cubed. Next is g squared. He has no like terms, so we just bring him straight down. And then the blue one, we have 3g minus 9g. That's negative 6g. And then we could have very quickly written down minus 10 or negative 10 because it's negative here, but don't forget, it's negative or subtracting negative 10, so that is positive. And that one's done. The number of economy-size cars rented in W weeks is represented by 152 plus 3W. The number of full-size cars rented in W weeks is represented by 99 plus 2W. So here I'm going to do some underlining. Okay. Write a polynomial that represents how many more economy cars are rented than full-size cars. So what that's going to look like is they're saying, hey, listen, economy is renting more than the full size. And so how you would come up with that is E minus F, economy minus F. And in fact, whoa, E minus F. Well, what I mean is economy is represented by that, right? And we're going to subtract the number of full-size cars, which is represented by that. And you know what? Since I didn't do it as much up there, I'll do it right here. Negative 99 minus 2W, 152 plus 3W. Let's simplify this now. 3W minus 2W is W, and 152 minus 99, let's see, that if you were to subtract 100, that'd be 52, but we didn't subtract 100, we subtracted 99, so that's going to be 53, plus 53, sorry. So there's that one. Find the sum or difference. Now they've just mixed it up for you. So here's what we're doing. We're doing g squared plus g squared. That's 2g squared. We got negative 9h squared plus 8h squared. Well, that's negative h squared. And then that guy's left over. Now, I will tell you that this is the right answer because it's it's in alphabetical order. A, B, C, D, E, F, G, then H squared. Okay? If you didn't write it like this, that's okay. Just know that this would be the preferred way to write that one. So same thing with this one. We have an M. He's going to be first. N will be second. Actually, N would be third because we have an M in. But I'm going to walk through this one, kind of slowly. So this guy drops down because we're not simplifying anything in that first set of parentheses. So we could just drop the parentheses. But next part, let's distribute this negative. So we have negative M squared minus 3mn. And then a negative 9n is plus 9n squared. So m squared, both negatives, that's negative 2m squared. Negative 5mn, negative 3mn, that's negative 8mn. And then we got our guy over here just left behind. So this is your final answer here. And that actually wraps up the whole thing on adding and subtracting polynomials. Let me know what questions you got. See ya.